Hello everyone, my name is Markus Sabadello. I am founder of a company called DanubeTech. It's a small software development and consulting company in Vienna, Austria. I contribute to a number of organizations, as you can see on the slide. Decentralized Identity Foundation is a consortium of a few dozen companies, large and small, working on decentralized identity technologies. Sovrin Foundation, I'm a member of the technical governance board of that foundation. You may have heard about it. It's a foundation to develop a distributed ledger and a protocol for self-sovereign identity, and I contribute to a number of standards or working groups and community groups at W3C Verifiable Credentials Working Group, W3C Community Credentials Community Group, and the Oasis XDI Technical Committee, which is a protocol and a data model for decentralized identity. I was supposed to do this talk together with Drummond Reed of a company called Ethereum, but he's not available, so I guess I'm doing this by myself. Masterclass on the DID universal resolver. So the last talk by Mike Schwartz and Yves Mailer, I think, was very impressive. As always, they presented UMA and related technologies, OAuth, OpenID Connect, which are very mature, right, and very well adopted and proven, and they are used out there by many companies for many different use cases. They are very stable and mature. In contrast to that, I'm going to offer some information and some content on something that's much more experimental, right? DIDs, decentralized identifiers, is something that's just emerging right now, just slowly coming up, slowly being developed, and so I will have sort of three parts in this talk. First, to introduce something called Decentralized Identifiers, DIDs, which is a specification. It's a technology, and then the second part talk about something called the universal resolver, which is an implementation of that technology. Then in the third part, talk a little bit more about what is that for and what can we do with it and what is this all about. So DIDs, decentralized identifiers. It's really about what people are calling self-sovereign identity, right? Unfortunately, I was only able to arrive at this conference yesterday, so I missed much of it, but my understanding is that SSI, self-sovereign identity, has been mentioned a few times, and it's really an emerging paradigm, emerging idea, and it's about, I think, trying to model or trying to build digital identity in the same way as identity works in the physical world. A lot of people who explain self-sovereign identity will say it's about decentralization, it's about privacy, it's about putting individuals back in control of their identity, of their data, and all of that is true, but at the core, I think this concept of self-sovereign identity has to do with the fact that we want identity in the digital world to work the same way as it works in the real world, and my identity is something that belongs to me, that is inherent to me, that's not given to me by someone. As a human being, I have a physical identity, psychological identity, maybe metaphysical identity as an individual, as a member of my family, in relations with the government, with civil society, with companies. If you saw the earlier talk by Kalia on the domains of identity, that's a very effective, I think, model to explain different parts of identity. So the question that the self-sovereign identity community is asking is, how do we get from that, this kind of inherent identity that every human being has in the real world, in the physical world, to the digital world? And traditionally, often the answer has been in order to establish a digital identity, I register somewhere, right? I choose a username, I choose a password, I go to some kind of service, I establish an account, the account is given to me by a service provider, I'm I become an entry in somebody's database, and that is not self-sovereign. The self-sovereign idea is that identity, the act that establishes a digital identity, the act that tries to model my physical self in the digital world. To do that transition should be something that starts with me, that doesn't require an external service provider, that doesn't require a username or something that is given to me by a party who can then also take it away from me again, right? So self-sovereign identity is the idea that I can generate my digital identity and then also control it and destroy it if I want without the help of central authorities or intermediaries, or through some kind of process that I do completely by myself. And to build identity systems, all the identity data models, identity protocols, identity architectures that we've been using for many years, I would argue, always require some kind of identifier, right? So we need ways to refer to individuals, to organizations, to businesses, also to things. We need ways to assign or to establish names and numbers to be able to refer to individuals and other entities. Without identifiers, I cannot really have relationships. I cannot have transactions. Without that, I cannot do data sharing or messaging or higher level concepts such as trust or reputation systems or social networks. Everything, all of these things require some kind of way to refer to things, requires identifiers. And so the idea of DIDs, decentralized identifiers, is to have a new kind of identifier in the digital world, a kind of identifier that satisfies the ideals of self-sovereign identity concept, an identifier that I can create myself, that's not given to me, right? If you have a username, Skype username, Facebook username, that's given to you. It can be taken away from you. If you think you own a domain name, you don't really own it, you just rent it, right? It can be taken away from you. So the idea is to have a new kind of identifier that has a number of interesting properties which are listed here. We'll look at that in some more detail. They're persistent, decentralized, dereferenceable, and cryptographically verifiable. These are properties of this new kind of identifier. DIDs are not DNS-based. They are not human readable, so I cannot tell you what my DID is, and you will remember it's a long string of numbers. So I could write it down, or I could encode it in a QR code, but it's not human memorable. It's not a human memorable string. So a little bit about the history. What's the current state of that, and where does this come from? A few years ago, there was a working group at the W3C on web payments working group. They tried to build a new payment protocol based on web infrastructure, and then they realized in order to do payments, you first need identity, and then they realized in order to do identity the right way, they need a new kind of identifier. And at the same time, another group, the Oasis XDI Technical Committee, which has been working on decentralized identity protocols for a long time, also realized that a new kind of identifier is needed that is not a domain name. And since then, in the last few years, through a number of workshops and conferences, such as the Internet Identity Workshop and the series of Rebooting the Web of Trust events, this idea has been developed more and more. There's been a government grant by the US Department of Homeland Security to develop this initial concept of a decentralized identifier, to develop the initial specifications. And then there are a few basic papers out there. So again, this is not a standard. This is early experimental technology, but there's some material out there. A paper called Decentralized Public Key Infrastructure. It's about the idea that you can do public key infrastructure without a central authority. And then a first implementer's draft, the first early specification drafts for decentralized identifiers. And the idea is now in the next year, 2019, to establish an actual W3C working group on DIDs, decentralized identifiers, which will then be standardized at some point. So what does this look like? This is an example of a DID, a decentralized identifier. It's a valid URI, so it's not something completely new. It's a new kind of URI. It consists of 3 parts. So it starts with DID colon. That's the URI scheme, kind of like HTTP or mail to or FTP. Then it has a method, and then it has a method-specific identifier. And this structure is a little bit like what you have with a URN, right? So in a URN, you also have the form where you have URN colon, and then maybe UUID colon, and then an identifier. So it's a little bit like that. And the method tells you, so there are different DID methods that tells you how exactly this kind of DID works. How is it created? How is it changed? How is it also deleted? Where is it registered? What's the mechanism to establish it, to register it? Remember, it's supposed to be registered in a self-sovereign way. You don't go to a website and create an account and then ask that website to create the DID for you, but it's created, you create it yourself. And basically these methods that allow DIDs to be created and managed, most of them, they don't have to, but most of them use DLTs, distributed ledger technologies, blockchains, because the structure and the mechanisms that blockchains provide align well with the idea that you have a way to register something that's not controlled by a central authority, right? So just like in Bitcoin, I can send coins between participants to exchange coins between Bitcoin addresses, and I don't have to ask someone, I don't have to register somewhere to get a Bitcoin address and participate there. So in a similar way, we can use blockchains or other decentralized networks. So it's not always a blockchain, but some kind of decentralized system that's not controlled by a central party. We use that to register these identifiers. In a way, they're similar to Bitcoin addresses, but and the method-specific identifier, that tells me that's an identifier that I control within this specific DID method. So just like in Bitcoin with a private key that I have in my wallet, I control the coins associated with a certain address. In the same way, here with a private key, also in a wallet, and we actually call that an identity wallet. I have private keys that allow me to control this specific DID. And what can we do with a DID? So if you remember on the previous slide, one of the features that these identifiers have, so one feature is decentralized because it's not controlled by a central party. Another feature is it's persistent, so it doesn't change. If I register this identifier once, I can have it forever. It doesn't go away. But a third feature is it's dereferenceable. So if I give this to you, if this is my DID and I give it to you, then you can do something with it. You can resolve it. You can dereference it and find out more about it. So in a way, these DIDs are like URNs because they are persistent. But in a way, they're also like URLs because they can be dereferenced, right? A URL points to a document. You can dereference it. But a URL that is based on domain names is not persistent because a domain name can be taken away. URNs, on the other side, are persistent, but you can't really do anything with it. You can't look up any information associated with URNs. So DIDs combine both properties. They are persistent and dereferenceable. And the process of dereferencing the DID is called DID resolution. So if you have one of these identifiers, then you can resolve it, which means you can look up and associate it, what's called a DID document. And the DID document contains basically metadata about the entity, the individual or organization or thing that the DID identifies. And primarily, that means two things. It means It means public keys. What is the public key or multiple public keys associated with that DID? And the other thing is a service endpoint. So how can I interact with the entity that is associated with the DID? So if you know the DID, you can look up this DID document. It's a JSON-LD document based on the RDF data model, JSON-LD serialization format. It's basically JSON, and you can see on the right side some example of a public key and a service endpoint that's associated with that DID. So if I give you my DID, you can look up what's my public key and how can you contact me, and that can be many things. So that's left open basically. DIDs are just a small building block of something larger. It's not a complete protocol or a complete service or a complete product. It's just a small component of other things. And so in the DID document, for example, to make a reference to the previous talk, I could have a personal OpenID Connect endpoint associated with my DID, or I could have my personal UMA authorization server associated with my DID, or my Mastodon server if you use federated messaging, could be even my Skype username on my personal website, but typically it will be some service that you can use to contact me, to interact with me. And this can change. So the DID document can be updated even when the DID stays the same. So that's one of the powerful features, really. I can give you a DID, and it's persistent, and you can always use it to interact with me. And I could change my keys. I could rotate my keys. I could change the services. I could change the location of my services. So it gives me data portability. If a certain service is hosted in this location today, I could change it tomorrow, move it to another location, and my DID will stay the same. So that's one of the features. And this process is called resolution, DID resolution. Now, there are these different DID methods. So the method again tells us where is the DID registered, and on the right side you see some examples, some blockchains, some distributed ledgers that allow me to register these identifiers, and they're all very different, right? So some of them are specifically made for this new technology. Some of them are specifically made for DIDs, such as the first two, Sovrin and Verifiable, if you heard about these. These are distributed ledgers specifically designed for registering self-sovereign identifiers, DIDs. But the others, Uport, for example, uses the Ethereum blockchain. Bitcoin, we all know, Blockstack uses a mix of the Bitcoin blockchain together with some kind of middle layer. ERC 725 is a popular smart contract pattern on the Ethereum blockchain that allows the establishment of identifiers. IPFS, you probably know, is not a blockchain, but it's also a decentralized storage system. So I could register a DID on any of these systems, and they provide the same functionality. They can always be resolved from the DID to the DID document. And that provides interoperability, and these different methods, these different technologies have different strengths and weaknesses, right? So Bitcoin, you could argue, is maybe the largest, most stable, most proven blockchains. If you want a very super reliable identifier, maybe you register it on that. On the other hand, Sovrin has a lot of other advantages. For example, when you want to register thousands of DIDs, many identifiers, then maybe Sovrin is more suitable. But the basic idea is to have this abstraction layer, registering, identifying any of these methods, and they still provide all the same functions. They can be resolved to the DID document to look up services, to look up public keys. All of them can be created, resolved, updated, and deleted. Well, on a blockchain, as we know, we can't delete things, but we can revoke things. So even a DID registered on the Bitcoin blockchain can be sort of marked on the ledger as revoked. So this is all still common functionality across all these methods. And so every single one of these methods has a small specification that talks about how exactly does a DID work on this ledger, and how does it work on this ledger, and how does it work on this ledger. And they have implementation of what's called a resolver, and that takes us to the second part. So how exactly does this resolution work, going from the identifier to the DID document, which contains the metadata about that identifier. So at DIF, again, Decentralized Identity Foundation is this consortium of a lot of companies, including large, well-known brands. One of the first, and DIF is working on open source implementations for self-sovereign identity, building blocks, libraries, components for decentralized identity. And one of the first projects is a tool called the Universal Resolver, which provides exactly this functionality of resolving a DID to a DID document using a system of different drivers. So now, Universal Resolver, you can think of that as a basic API with just one very simple function. You hand it the DID, and it returns the DID document. But underneath, it has a set of drivers for each one of the DID methods, and the drivers know exactly how to talk to this specific blockchain or distributed ledger or other decentralized system. So, and internally, they work completely different, right? Bitcoin is permissioned public system. Sovrin Bitcoin is a permissionless public blockchain. Sovrin is a permissioned public blockchain. Some of them have smart contracts, some of them have coins, some of them don't, so there are a lot of differences. But a resolver, a driver for this resolver tool knows the specifics and can look up the DID in any of these systems. And you could compare this concept of a resolver a little bit to in the DNS system. This would be the equivalent to bind, right? So in DNS, you have domain names, and you work with domain names, and you can resolve a domain name to an IP address, and you use a DNS resolve, a DNS library that knows how to talk to the name servers and retrieve the data associated with the domain name. In the same way, you could think of this as a tool that you can hand the DID, and it returns the DID document from these different systems. And I'll do a demonstration quickly in between. So there's a public instance of this universal resolver running, probably, maybe this is too small, but running at URL uniresolver.io. This is a publicly hosted instance of this tool, Universal Resolver, and you can see you can hand it the DID, and if you click on resolve, then it will return here on the second tab. It will return the DID document, and as we discussed, it returns the current public key associated with the identifier, current service endpoints associated with the identifier. Again, these could change. The contents of this could change. The basic metadata that you need to start interacting with the individual or with the organization or the thing identified with this DID, but this can change, and the DID is persistent. It will stay the same. The tool, it has a few other functions. It can also display the same information in a more human readable, in a more presentable way, and it can return metadata about the resolution process. It can return some data about what happened behind the scenes. And the interesting part, again, here are the different drivers, and here's a drop-down box with examples, and you can see many different DIDs from all these different DID methods, from all these different backend systems or target systems. So the first one is that we just tried is an example of a DID registered on the Sovrin ledger, but try one of these, did call on BTCR, that's the method identifier for DIDs registered on Bitcoin. If I resolve that, I will again get a DID document following the same structure. But in this case, it comes from a completely different blockchain. And so here's one, for example, that has many different service endpoints. And another thing you will notice is that this method-specific identifier, this part that comes after the method, this looks quite different for every single one of the methods. And this depends on the method itself, and it's up to the method to define what it is. In the case of Sovrin, the method-specific identifier is actually half of the initial public key. In the case of Bitcoin, it's something else. It's a pointer to a specific Bitcoin transaction inside a specific block on the Bitcoin blockchain. And in the case of ERC725, for example, this is the address of an Ethereum smart contract. So this could be different for each one of the methods, but it is whatever information is required to look up the DID document. And these specifics, the specifics of the individual methods, they are defined in a specific specification, specific DID method spec, and implemented using one driver that knows how to resolve this specific method. In the W3C credentials community group, which we're maintaining a registry. So there's a registry of DID methods that are currently more or less being defined. You can see all of them are provisional, right? So this is still early, but you can see that people are working on different kinds of DIDs. And one more thing maybe. So all DIDs can be resolved to a DID document, but it doesn't mean that the DID document is actually stored in plain text on the blockchain or on the ledger. It could also be dynamically constructed. So what the resolver with the drivers, what they do is they retrieve all the information that goes into the DID document, but the DID document could be stored on the ledger in plain text, in which case this is a very trivial process, or the information that goes into the DID document can also be dynamically constructed during the resolution process. But that's a detail of what happens behind the scenes. How would such a resolver be used? If you look at the bottom part of the diagram, you see there are two apps, and one of them is sort of directly attached to the resolver, and the other one, there's an HTTP GET going to the resolver. What I demonstrated here, this is again a public instance of this resolver, but the resolver, just like a DNS resolver, can just be part of an application or a service. So if you build something that works with DIDs, you would not call this service, right? Because someone is hosting that. It's again some kind of trusted party that you would use to resolve an identifier. So instead of using this service, you would have the resolver and the drivers. You would integrate that into your own application, which then talks directly to the blockchains to retrieve this information. So you would not use this service as an intermediary that's hosted by someone, but you would either host it yourself or integrate it into your app directly. Yeah, again, we covered this already. On the right side, you see a lot of the logos of members of the Decentralized Identity Foundation. Some of them are actively contributing to this project. So the idea is that for each one of these methods, for Sovrin DIDs, Ethereum DIDs, Bitcoin DIDs, there's a certain community that's specifying them, that's updating and working on the driver that knows how to resolve them. And yeah, we discussed the resolver could be run as a hosted service, could be integrated in directly in applications. It could also be run from a command line. So here's an example how a simple command line command using the curl command would contact this resolver with a query for a DID, and again it returns the DID document. So there are different ways how this could be used, how this component could be used as part of a larger architecture. So what is this for, right? So again, this is just a small building block. It's just a new kind of identifier, and it can be resolved, and it has interesting properties, persistence, decentralization, and so on. But what is this for? So one of the initial motivations or initial communities or use cases that really motivated work on DIDs was verifiable credentials, which used to be known as verifiable claims. It's now called verifiable credentials. It's now a W3C working group, so people are actually working on standardizing this. This is a format, a data format for attestations, for semantic statements made by an issuer about a subject. So it's anything that anyone could say about someone else, right? Any kind of claim, whether it's a driver's license or citizenship or birthday or also some kind of peer-to-peer attestation, right? I could say about one of you that you're a great Node.js coder or anything like that. Any statement made by someone about someone. So there's an issuer and there's a subject, and this W3C working group standardizes the format. It's just like the DID documents that we saw earlier. This format is also based on the RDF graph model and the JSON-LD serialization format, which both have their roots in the semantic web originally, right? So the semantic web, the idea that the web is not just a web of human-readable documents, but the web is really a web of semantic and machine understandable data. The same kind of technology data model is used here. So unlike in early OpenID or SAML or information card or technologies like that, where claims were mostly key value pairs, right? There's a key, birthday, and then there's a value here. This model actually uses the full power of the semantic web, where you can have ontologies and classes and properties and so on. So you could have quite complex statements. But the bottom line is there's an issuer and there's a subject, and the motivation was that this should be decentralized, this should be self-sovereign. So here is where we would use the DIDs. This is an example where both the issuer, in this case, in the example you can see the issuer is identified by a sovereign DID, and the subject in the claim block, the subject is identified by a BTCR DID. So one of them has their identifier registered on Sovrin, the other one has the identifier registered on Bitcoin, and they can still make claims about each other, make statements about each other. And there's a proof attached to that. So the proof is basically a signature by the issuer. And this is a separate specification, by the way, link data proofs, how to sign RDF data. And so in the diagram, you can see that this verifiable credential is given by the issuer to the holder, to the identity owner, to the individual, and the individual can present this credential to a verifier, which is not a name for a relying party. They can do that whenever they want. And unlike in OpenID, unlike what you have in OpenID Connect or information cards, back then there's no phoning home, right? That's what it's called. So there's no arrow between the issuer and the verifier at the time when the person, the individual presents the credential. How does the relying party check the signature here? So how does the relying party verify that this credential was indeed comes from a certain issuer, if there's no callback between the verifier and the issuer, well, that happens through DID resolution, right? So if I'm the verifier, the relying party on the right side, and somebody presents this to me and it says issuer and it says proof, then using the DID resolution process, using this universal resolver tool, I can look up what's the public key associated with this issuer DID, and with that public key I can validate the signature on the credential. So this is one example where DIDs are really being used, and what has motivated DIDs. Another topic which is even simpler than that, which is maybe the most straightforward thing to do with this new kind of identifier is something that we've been calling DID auth. It's again not something that's a standard. There's not even a real specification about this. It's just the concept of having a DID-based authentication protocol. So if I have an identifier that I generated by myself with an identity wallet, with a private key on a blockchain, so I have this identifier that is not dependent on any service. It was not given to me by some kind of website or service provider. I created it by myself, and I have a key that controls it. And maybe the most straightforward thing, or the most immediate thing I could do with that is just in some kind of online transaction interaction prove that I control a certain DID, and that's what we've been calling DID auth. And it's not defined what kind of protocol that would be. It could reuse a lot of what OpenID Connect or FIDO web authentication or other standards already provide. So it's not necessarily a new thing, but it's a way how I can prove control of a certain DID through a challenge and response pattern. And you will see that here in this diagram, there's no identity provider, right? There's no third party or no service that I rely on that issues a token or issues some kind of attestation who I am. But when I interact with a relying party, when I go to let's say a website, right? Classic login, authenticating to a website, logging in to a website. I go to that website. Now with DIDs, what I can do is I can give my DID to that website. They can resolve it. They can send me a challenge, and I can sign that challenge with my private key in my identity wallet and return the response to the website. And again, I could rotate my keys. I could change my service endpoints, and I will still have the same identifier with that website. So in a way, what this allows me to do semantically, this allows me to prove that I am me, right? So this sounds a bit stupid maybe, but I believe that with the technologies that we've had in this community for a long time, we've never really had a protocol or a way to prove to a relying party that I am me. So with OpenID and all these other protocols, I've always proven that somebody says that I have a certain username, right? I go to a relying party, and the identity provider says that I have a certain identifier with that identity provider, and they say that, and that's why I'm allowed to log in to a website. So with DIDs, we can do something in a self-sovereign way, again, just to prove with my own private key that only I control, prove that I am me. We have a paper which is a draft right now. It's not done, but where we go into a little bit more detail for this idea called DID auth. There are a lot of diagrams, a lot of different flows how this could work. Logging in to a website with a browser, a QR code being displayed to me. So for example, a website could display a QR code to me. I scan the QR code. In the QR code, there's there's a challenge, and with my private key associated with the DID, I sign that challenge and return it to the web server where I'm logging in. So there are many different flows, either with a mobile app scanning a QR code, or with redirects where I go to a relying party. The relying party redirects me to a website where I authenticate and I get redirected back. So there are lots of flows, and lots of them look similar to what OpenID Connect and FIDO Web Authentication and others already provide, and I don't want to go into too much detail, but you see there's always just an identity owner and a relying party. There's not a separate identity provider, because I'm my own identity provider. That's the essence of DIDs and self-sovereign identity. So these are two developments that are happening. Verifiable credentials, did auth based on DIDs, and then of course there's entire concept or projects and different architectures evolving services that act on my behalf. What some years ago we were calling personal clouds, personal data stores. Now we call that hubs or agents. So the idea is that I have a DID. It's an identifier, and it points to a service hosted somewhere that acts on my behalf, that can manage my verifiable credentials, that can help me execute a did auth flow, right? The challenge and response that's exchanged between me and the relying party could happen through a service that's hosted somewhere, where it says the cloud hub layer. So this is sometimes was also used to be called identity container or personal cloud or data vault, or in Sovrin, for example, this is called an agent. It's something that's not on the ledger, but that acts on my behalf, that a service that helps me manage my claims, my data, my identity. And again, this could be moved, right? So my DID can stay the same, but I have full data portability. So a number of projects are working on an architecture like that, where you have a combination of DIDs and agents, and that's how identity information, credentials, and proofs and data and authentication processes happen. This is my almost last slide. Just a lot of other things that are happening right now. Of course, one important topic is always key management. So if we start with this premise that as an individual, I create my own identifier, which is controlled by my own private key, then what happens when I lose it, right? A problem that's well known in the cryptocurrency space. One answer is, of course, that with more sovereignty comes more responsibility, right? There is no centralized Facebook that I can call when I forget my password. So one simple answer would be, if you lose your key, then you lose your identity. But of course, people are also working on key recovery, social key sharing. This idea that I could have a recovery key, split it up in a few parts, give it to a few best friends. If I lose my key, if I lose my app with my private keys, I could call my friends together. They could reconstruct a key that allows me to take back control of my DID. Could be escrow services. Maybe I split up my key, and half of it I give to my bank, and the other half I give to my friends. Again, a company, Evonym, they've done some research on this. They've done some interviews with students, and they asked them, what kind of mechanism would you prefer for backing up your key? Would you print it out as a QR code? And if you print it out, where would you put the paper? Or would you store it with your friends, or would you store it with your bank? There were some interesting answers. I think the number one answer was they would store their recovery key on their Google Drive, which as a European who is very much concerned about privacy and with our GDPR things, happening. This is an answer that's a little bit strange, but there are different options, and people are working on protocols for that. And lots of other things that could be done with DIDs. Basically, everywhere you use a PKI, everywhere where you have key pairs, you could use DIDs instead of the public keys. You could have a TLS connection that's based not on a hard-coded certificate or a hard-coded public key, or a certificate based on a centralized certificate authority. That's how TLS certificates work right now, right? But you could base that on DIDs. You could base SSH, PGP. You could do all that with DIDs, and you have a number of advantages. Okay, slowly we're running out of time. You see a lot of other things where people are working on integrating these decentralized identifiers with a lot of things that exist already. There's concrete work happening on all of this. Maybe one final thought that's actually really important. I mentioned it briefly in the beginning. You could have many DIDs, right? So there's this whole concept of directed identity. That's what Kim Cameron called it. I want to avoid correlation. I want to avoid linkability. If I log into a website, I want to use a different identifier than when I log in to the other website. So that we call that pairwise pseudonymous DIDs. Ideally, maybe I want different DIDs for every relationship, for every transaction, even. So DIDs and apps and agents and wallets should support that. There's even a concept of off-ledger DIDs. That's a very recent development. So if I have a DID, an identifier that I only use for one specific relationship, and there's this concept of a micro-ledger, which is a ledger that only exists between me and you. So it's a DID that's not even stored on a public blockchain like Bitcoin or Sovrin, but there's just a relationship, a connection between me and you, and we have a small ledger where we keep track of each other's DID that we only use for this one relationship, and we can still have all the benefits like data portability, persistence of the identifier without having to publish it and without sharing it with others. So a lot of interesting things happening right now. Here's again some of the current ecosystem, what's happening, but I'll skip that and say thank you, and maybe there's some questions. Is it really self-sovereign if you have to go to a registry? Well, you're not going to a registry, right? There's no website where you register. You have an app, and in that app you have a wallet where you generate your key pair, and you write something to the blockchain. You write something to the ledger, and that establishes your DID. So there's no registry service. There's a registration process, but the registration process for the DID is only between you and the ledger. So what happens if someone hacks the resolver, and what does it mean to rely on the resolver? And isn't that a weak point, right? That could be spoofed and so on. So again, this here is just one public instance of the resolver that in an actual application you would not use that, but you would integrate a resolver into your own application, and you would. And that resolver talks directly to the ledger, to the blockchain. So you talk directly to Bitcoin or directly to Sovrin. There's no one in between who could intercept or manipulate that. And the code of this resolver is open source, so you can inspect it. You can look at the code. You can see the code talks directly to the blockchain. It doesn't talk to any intermediary service. you retrieve the data directly from the ledger, so there's no one in between who could intercept that. But it's not a third party. It's your application, your service contains that. It's a part of your application. It doesn't make a call to. It doesn't call any API. It's not an API that you call. It's something that's inside your app or your service. You're not relying on anyone. Yeah.
Governments know all my different deeds that are related to me. So how do you protect, because the whole point of all this is to protect the privacy, my privacy, but at the end of the day, the government know all my different identities because he has tested something for me, the physical person.
Yeah, so that's a detailed question about how these credentials work with DID. So you can and you should have many different DIDs. When you receive the credential, like let's say your driver's license, you receive the credential from the issuer, which is the Department of Motor Vehicles, right? You give them one DID. They know you by one DID, and they issue the credential to that one DID. Now, when you go to a relying party and you use that credential, you give that relying party a different DID, and if you interact with 10 relying parties, you give each one of them a different DID, but there are cryptographic technologies, zero knowledge proofs where you don't have to go back to the issuer every time for them to issue a new credential to a new DID, but you can actually construct, so this is cryptography, this is zero knowledge proofs, but you can construct a dynamic proof for each one of these relying parties that you go to, who all know you by a different DID that's different from the DID that you use for the issuer, and the proof will still be valid. So the issuer only gives you the credential once, issued to one DID, and you can use it for many other DIDs. You don't have to get it reissued, and it still works. This is the CL signatures, Kamenishli Sanskaya signatures. It's a certain kind of.
So are we generating a blockchain, a different DID each time I have to prove to someone? But we know that today the blockchain is less capable of handling many requests of writing to the ledger just for money exchange, virtual money exchange. Now we are talking about exchanging attributes. So the number of requests to write to the ledger will be exponential from what we have today. So we are already eating scalability performance points, and we hope to go beyond that.
So scalability of these DIDs, yes, the ideal is that you have many different DIDs for each relying party, each relationship. But again, there's this new concept that you can have DIDs on a peer-to-peer microledger, which are DIDs that don't have to be registered on a blockchain. So if you take that into account, then you have scalability, and you can have thousands or millions of DIDs without the cost of actually registering them on a public blockchain that's constrained in performance.